Okay. Uh, boys and girls, it's going to take us a little while to get through this. I'd like to be able to have you have some time at the end. You will also have all day tomorrow to work on your homework, only for the reason because second hour I need to teach them, and I don't want to get ahead in this class. Okay, so that's where we're at. So it says find f of a plus h minus f of a all over h for those two functions. Now I want you to look. Yesterday we did these, right? Can you do those? We're capable. So now let's try something else. And if you look at this, it says find f of a plus h minus f of a all over h. If you look at this piece over here, it says f prime of x, which actually means the derivative of the function, is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So the reason why we're doing this right now is to expose you to a little bit of what you will see in calculus. You have to get really good at using that. And as you can see, a lot of it is algebra and being able to reduce it. And although a lot of people say, you ask them what their favorite math is, they're like, algebra, love algebra. Really? You like the algebra, you know how to do, but what about when it involves a complex fraction, multiplying by conjugates, square roots in the numerator and the denominator? What if it has that? Then how much do you really love algebra? So we're going to learn to love it, and we're going to try this right here. Here's what you need to do first. We need to do f of a plus h, and we need to do f of a. Let's first work with this first function, and then we'll do the second one. So for f of x is equal to x squared, let's first identify this. What is f of a? Very good, a squared. What is f of a plus h? Very good, Elizabeth. A plus h quantity squared, which is a squared plus 2ah plus h squared. I now have my two components to this formula, right? So I can now evaluate it. I have f of a plus h, which is a squared plus 2ah plus h squared minus f of a is what? A squared all over h. So we want to simplify that expression. What cancels? The a squareds will cancel, which leaves you with a 2ah plus h squared over h. There is a greatest common factor of h in the numerator. H times 2a plus h all over h. Those cancel. The result is 2a plus h. That wasn't too bad, was it? You're going to have to practice that on your assignment, and I'm going to encourage you guys that when you do, you set it up like I did. You do f of a equals a squared. You do that first. F of a plus h. So figure out what those two pieces are. Then you subtract them, like it says here, and divide it by h. Let's try one more. First, what's that? Yeah. What's that? How's that? Too far? Okay. Let's try this. F of x equals 2x minus 3. I want to do the same thing. What is f of a? 2a minus 3. There goes the phone. I'm popular. Well, see what YouTube world just missed? That video would have been a whole lot better if we went to pause it, right? I mean, they would have loved that. Okay. Now, f of a plus h. What's that? 2 times a plus h minus 3, right? Which is? Danny, you asked where am I getting this? I want to find f of a plus h minus f of a all over h. So I need to first evaluate f of a plus h and f of a. I'm going to take these two results and subtract them. Do you see that this is f of a plus h? Do you see that this is f of a? Now I need to subtract them and divide by h to find this. That was the answer, yeah. Okay. Okay. So, Casey, no. We want to make sure this works out. So I want to find f of a plus h minus f of a all over h. That's what I want to evaluate. What is f of a plus h? Do you see that f of a plus h is this? So I have 2a plus 2h minus 3. So that's my f of a plus h. Minus, what is f of a? 2a minus 3. All over. See how that's good now? There we go. Okay, what's going to cancel here? 2a and negative 2a, those will cancel. What else is going to cancel? The 3's. I have a minus 3 and minus a negative 3, so those are going to cancel as well. So I'm left with 2h over h, which is equal to 2. Yes? No? Better? Danny, you got it? So you and Casey got it. Everybody else has it. Billy Barber has it. Mallory Gill loves it. Okay, take out your graphing calculators, please. Yes. No, if it was 2 plus h divided by h, that would be dividing off parts. So, what we've done so far is we've been evaluating functions. Okay? Now, did I misspell it? Is that what you're... Okay. I did. It's A-B-L-E. Okay. So, what we want to do now is we've been evaluating functions. What if... Can I just choose any number I want, plug it into a function? It depends on the type of function it is. For example, the square root of 9 minus x. I can't just plug in any number for x and evaluate it. And to show you that, I want to look at the graph. So turn your calculators on. Go into y equals. And it says square root of 9 minus x. So I'm going to type that in. Square root 9 minus x. And I'm going to view it in a standard viewing window. So I'm going to go zoom standard. If I plug in negative 4 in for x, do I have an output that corresponds with negative 4? Yeah. If I plug in 0, do I have an output that corresponds? If I plug in positive 10, do I have an output that corresponds? No, I can't plug in 10. Why? Okay, so as looking at the graph, I can't plug in 10 because I don't have a corresponding y value. But without looking at the graph, why can't you plug in 10 here? You get a negative underneath the square root, which is an imaginary result. So what we have to do is we have to use our knowledge about what we know about algebra in order to state the domain. Would you guys agree that if I have a square root, anything underneath the square root must be either greater than or equal to 0? So I take 9 minus x, and I set that greater than or equal to 0 to solve for what possible domain values I can have. How do I solve for that? Minus 9, so negative x is greater than or equal to negative 9. And switch the sign. X has to be less than or equal to 9. Would you guys agree that when we looked at the graph, all the x values that are available are either less than or equal to 9? So if I were to express the domain in interval notation, I would say that we are going to go from negative infinity all the way up to 9, and I'm going to close that bracket because I can include 9. You can have 0 under a square root, right? Because the square root of 0 is 0. I know that anything under a square root has to be greater than or equal to 0. How about x plus 3 over x minus 2? That's a rational function. Anytime you have a rational, you need to be careful about the denominator. What number can we never divide by? 0. So I have to make sure that the denominator does not equal 2. What? No, I'm sorry. Okay. The denominator does not equal 0, so I have to solve that equation. In order to solve that equation, I add x to both sides. I get x cannot be 2. So if you were, how would you express that in interval notation? Is it okay to have or is it okay to have 0 in the numerator? Yeah, you can have 0 in the numerator. You just can't have 0 in the denominator. So we're not worried about this negative 3 up here, but we can't have 0 in the denominator. 2 over x squared minus x minus 6. Again, I have a rational function. The denominator cannot be equal to what? 0. I have to solve that. What do you want to do? Factor. X minus 3 times x plus 2 is equal to 0, or does not equal 0. So therefore, x cannot be 3 or negative 2. How would you express that in interval notation? Right? I excluded negative 2. I excluded positive 3. That's all I'm doing. Now, excellent mathematicians have more than one way to confirm their answer. I'm going to show you guys how to make sure that we did this correctly. Let's look at our calculators. Let's type this in. On the top, I have 2, and I'm going to divide by. Now, be very careful because I want to divide by everything, right? If you were to type in x squared minus x minus 6, that just takes 2 and divide it by x squared. And then it subtracts 6, and then it subtracts x, then it subtracts 6. I want to divide everything, so what do I have to do? Insert some parentheses around that stuff. So I want to divide by parentheses x squared and parentheses around my 6. That's what I want. Okay, now I'm going to graph it in a little bit different viewing window. Let's go window, and instead of negative 10, positive 10, let's go negative 5 to positive 5. And let's go negative 5 to positive 5. Now, I'm going to warn you guys, those of you who have TI-83s, yours is going to look a little bit, yours is going to look the same as mine. Those of you who have TI-84s, yours is going to look a little bit different. As I press graph here, you can see, look what happens here. As I scroll along, okay, look what happens to the graph when I get to negative 2. As I scroll over, all of a sudden right now I'm at about negative 2. What happens to the graph? It jumps way up there and jumps way down there. That vertical line you see is what we would call a vertical asymptote. A lot of you guys don't have that, right? Question. Yes. Now, so you can see that something weird happens at -2. -2 is not within the domain. And then you can see that you have another graph here between -2 and +3. And then you have another one of these vertical asymptotes. And then after 3, you have more of the graph. So you can see your graph confirms that -2 and +3 are not in the domains. In fact, if you were to go to the table and you were to type in -2 and +3, you can see that you get errors for both of those. It's not in the domain. If you plug it in, you get 0 in the denominator. It can't calculate it. Punch in any other value like 5 or, say, 6 or -4, and you can see that you do get values. Okay? So we could confirm algebraically. Let's do another one. Cubed root. Let's type it in. How do you type in cubed root into a calculator? Where do you get a cubed root from? Math, we could grab number 4, which is that cubed root. And I think I have, what, 2x plus 5? So 2x plus 5, parentheses. I don't generally type it in like that. I go parentheses, 2x plus 5, and I take it to the 1/3 power. Now, that's how I generally do it. It doesn't matter, however you want to do it. I should probably do it the other way, but that's how I do it. These are just going to graph right on top of themselves. They're the same thing. As I press graph there, this is kind of a cool shape. If I plug in 2, do I get a result? If I plug in 0, do I get a result? If I plug in -3, do I get a result? If you plug in any number, you get a result, right? Because you can take the cubed root of negative numbers, can't you? What's the cubed root of -1? -1. What's the cubed root of -8? -2. So you can take the cubed root of any kind of number. So therefore, domain is all real numbers. How would you express all real numbers in interval notation? -infinity to +infinity. Does it make you happy just to write that infinity symbol? Makes you feel really smart. All right, 9 minus x squared. I have a square root. What can I have underneath the square root sign? I can't have negatives. So 9 minus x squared must be greater than or equal to 0. We learned how to solve quadratic inequalities just last unit. I start by factoring. How does this factor? Three minus x and 3 plus x. So my solutions are 3 and -3. And as I graph those, is this a parabola that goes up or down? Down because of the -x squared. I'm wondering, where is this parabola greater than 0? It's negative here. It's positive there. It's negative there. So where's the interval where that's positive? That's the domain. We can include -3 and +3 because it can equal 0. It's okay to take the square root of 0. So again, what we learned last unit, you need to apply now to further understanding to be able to do this. So you got to know how to solve those type of inequalities. And we try one more. Oh, let's confirm it on our calculator. I like that. Square root 9 minus x squared. If you graph that, does that confirm that our domain is between -3 and +3? Yeah, kind of neat, huh? It's a semicircle. Wouldn't it what? Oh, it wants to make a circle. Why can't your calculator generate a circle? Because it's graphing what type of things? Functions right now. The calculator can't graph a circle. Watch this. We graph the positive portion of the circle. Now I'm going to graph the negative portion of the circle. It's an oval because we're not viewing it in zoom square. Zoom square number 5. Now it's going to be a perfect. Oh, the calculator just isn't smart. See, it can't put pixels on top of one another because then it wouldn't be a function. So your calculator is just too stupid. So anyway, yeah, isn't that kind of neat? Look at all the things that we're learning today. All right, okay. All right, let's do the last one. F of x is the square root of x over x squared minus x. I got 2 things happening here. What are the 2 things I need to be aware of? Square root and can't be 0 in the denominator. Well, some of that overlaps, and we have to look where that overlaps. So in the top, x has to be greater than or equal to 0. Okay, I took care of the top. That was easy, right? In the bottom, x squared minus x cannot be equal to what? 0. How do I solve that? X times x minus 1. So 0 and 1. So x cannot be 0 or 1. Does that conflict with this? Yeah. So I can use x is greater than or equal to 0. I can use this, but I have to modify it to exclude these 2 values. So I can't start at 0. What do I have to start at? I could start at 0, but I have to have a parenthesis there. And I go to what? 1 union with 1 to infinity. So that way I've excluded 0 and I've excluded 1 and I have everything else that's positive. Yeah? Got to look hard at these, you guys. This assignment, got to really dig deep. This is some of the harder stuff that we do during this unit. It starts off right away with domain. That's hard for people to think through. But trust me, you can do it. Okay? So I'm going to put your assignment on the board. You guys have all day tomorrow to work on the assignment because I need to teach the other class. Oh, fortunate are you. By the way, this assignment is slightly different than what I gave second hour. It's a little bit longer. Don't worry, I'm gonna add to their assignment tomorrow. So. Man, I am sweating like a pig. This is ridiculous. Is it not hot in here? All right, I'll teach from the back wall. Well, look at all the work I did. I used 5 boards. But nobody would have been able to see it. I mean, my shoulders are pretty wide. What? They don't have to memorize. They need to know how to do it. I mean, I would, I asked them afterwards. I said, if I gave you a problem similar to what we started with, would you be able to get all the way to the end? And 2/3 of them raised their hand. They said, yep, we could do it now. Yeah, we said it would take, half an hour, 45 minutes to maybe get it. But so you got to be willing to, if you want to be a great mathematician, got to put the work in.